Hi, the doctor is in. I'm Dr. LB, and I am here to help you through your mathematical difficulties. Let's get started. Today we're going to look at increasing, decreasing, and constant functions, and then we're going to find the relative minimum and relative maximum. So, a function is increasing if for 2 points x1, x2 in some open interval I, f of x1 is less than f of x2 whenever x1 is less than x2. Now, that means exactly what you think it means. If you look from left to right and the function is steadily going up, you're increasing. A function is decreasing if f of x of 1 is greater than f of x of 2 whenever x of 1 is less than x of 2. Now again, it is what you think it is. As you look from left to right, the function is decreasing. And a function is constant if f of x of 1 equals f of x of 2. So basically, if you're looking from left to right and it stays straight on a horizontal line, it is a constant function. So let's look at an example and let's find intervals on which the function is increasing, decreasing, or constant. So we're going to look at the first graph here. And if you notice, this is a parabola. It has a peak right here. If you look from left to right, we are going to be what? Increasing. The graph is steadily going up. So we look from negative infinity all the way up to 1. Now we look at the x values to determine increasing or decreasing. And then at 1, we start going down until we get to infinity. Now if you notice, we use open intervals for increasing, decreasing, constant. Let's look at another one. So if we look at this graph, notice that at this graph, you have dots here and there, which means that's where the graph starts, that's where the graph ends. In the other graph, we did not have that. So we had to put in negative infinity and positive infinity. But as we look from left to right, this graph is increasing. So remember open intervals, -5 all the way up to -2. And also remember that we are looking at the x values. Now if you look here at 4, the graph starts going up again all the way to 5. And this function is decreasing. If you look back at -2, it's going down until we get to 2. And it is constant starting at 2 and going over to 4. Increasing, decreasing, and constant. Now, let's talk about relative maximum and relative minimum. A function has a relative maximum at some point f of a. Now we're talking about y values. If there's an open interval containing f of a such that f of a is bigger than all other function values on that particular interval. So here we have a relative maximum. A relative minimum is at f of b. Again, we're looking at y values for relative minimum values. If f of b is less than f of x for all x in that interval. Okay? So that's our relative minimum. It is what you think it is. Honing in on a particular interval is the highest and or lowest value. So let's look at an example. And let's find the relative minimum and relative maximum. So if you look here, here, and here, those are the peaks on our graph. Okay? So we have relative minimums occurs in two places. It occurs at x equals -2. But remember we said that function value, that y value is the actual minimum. So what that means is that the relative minimum, if you look down here, that y value is -15. And some particular books and some instructors, they make you actually label the point 2 comma -15. But that maximum is really that y value. Excuse me, minimum here. We have another relative minimum that occurs at x equals 2. And again, at the same y value of 15. So this relative minimum is -15. So we have 2 comma -15 here. And then for the relative max, it occurs at x equals 0. And the relative max would be 9 in this case. So that we have a value or a point of 0 comma 9. So remember that Dr. LB is always in. Please come back for more math help.